Hello my dear students, welcome back to Learn Physics. In today's video, we are going to discuss about the new portion, that is kinematics. So last class we completed the error, measurement and errors. That one we completed. So please, as I said in the previous video, please try to do some more this worksheets about that chapter also. So today we are starting with kinematics. Kinematics means motion in one dimension, two dimension will be there. Okay, so first we are going to consider what is distance. Definitions and all you know very well. Distance, the total distance travelled, and length of the path travelled by the object. Displacement is the distance between the final position and initial position. So if I am considering an object which is placed at the point R1, see at A, from origin it is at a distance R1. Okay, then here now it is reaching to the point B, which is at a distance R2. Then this AB will be the displacement, final R2 minus R1. Final position minus initial position will be the displacement of the particle. That is delta R, or we can say that is R2 minus R1. This will be the displacement. Okay, now next is, so how can we find out this R2 minus, suppose if R1 I am representing like 2i plus 3j, and R2 if I am representing like 5i plus 6j. Then R2 minus R1, how I should find out? I can subtract the I part together and I can subtract the j part together. That's how we should find out the displacement. R2 minus R1 will be equal to 3i plus 3j. This is what we will get for the finding out the displacement. So distance, displacement. After that, speed and velocity. Speed is a scalar quantity and velocity is a vector quantity. Distance travelled divided by time is speed. Displacement divided by time will be velocity. So we will be, velocity means we will be considering the direction also. In the case of uniform motion, the object will be moving in straight line with constant velocity. In those cases, distance and displacement, speed and velocity will be almost same itself, because it's moving in a one uniform motion. It's a straight line motion. That is, in one dimensional motion, we will be getting both at the same value itself. Okay, so magnitude, when we are comparing, it will be magnitude of velocity will be, and speed will remain same. And velocity can be a positive value, negative value or zero value, but the speed will always be a positive value. Then how can we find out the average velocity? That means suppose the object will be moving with an object is covering a distance. See, d distance it is covering. In that d distance, half of the time maybe for some interval of time it will be moving with one particular velocity, and next interval of time it will be moving with another particular velocity. Then what will be the average velocity? Okay, to find out the average velocity, how we can find out the average velocity of the particle? Average velocity will be equal to total displacement divided by total time. Average velocity will be equal to total displacement divided by total time. That is average velocity. And in that, different, we need to consider many things while finding out the average velocity. Suppose questions can come like, see, if half of the time, see, this is d is the distance between these 2 points, A and B. Between these 2 points, d is the distance. And here in this distance, half of the time, it is taking t interval of time for completing from A to B. In that, half of the time it is moving with in t by 2. It is moving with the velocity v1. Next t by 2, it is moving with velocity v2. Then how can we find out the average velocity? I'll tell you the condition once more. From A to B, the distance is d. Half of the time it is taking totally t time interval. In half of the time it is moving with velocity v1 and next half of the time it is moving with velocity v2. Then we need to find out the average velocity. V average will be equal to v1 plus v2 divided by 2. Okay, this one you can by heart. Average velocity, if from A to B it has a distance d and it is covering in t interval of time. Half of the time it is traveling with velocity v1 and half of the time it is traveling with velocity v2. Then the average velocity will be equal to v1 plus v2 divided by 2. Next, suppose object is from A to B, moving from A to B. Here in this half of the distance, d by 2 distance, it is traveling with the velocity v1 and next d by 2 distance it is traveling with the velocity v2. Then what will be the average velocity? V average will be equal to 2v1 v2 divided by v1 plus v2. So clear? So these two formulas you should by heart. Okay, average velocity, if half of the time if it is moving with this one velocity and the next half it is moving with another velocity, average velocity will be v1 plus v2 by 2. But instead of that, if half of the distance, if it is coming with one velocity and next half with another velocity, average velocity will be 2v1 v2 divided by v1 plus v2. Then to find out the velocity, if the object is moving with a particular velocity, it's uniform motion. If the object is under uniform motion, what about its velocity? Velocity will be constant. So you can, to find out the velocity, distance divided by time, you can consider if it is the object is under uniform motion. And there also in uniform motion, when we are considering uniform motion, velocity will be remaining constant. Uniform motion means velocity remains constant and therefore acceleration will be equal to 0. And when the object is under uniform motion, velocity will remain constant and acceleration will be equal to 0. This is about the average velocity. And then next is instantaneous velocity. Velocity at a particular instant of time. Instant of time, how we can find out? See, delta V or dx by dt. We can find out instantaneous velocity will be equal to dx by dt. To find out the dx by dt, you should know how to find out the differentiation, how to use the differentiation. This one I am going to tell only for the sake of physics. Okay, for doing the numericals from physics, dx by dt, how we can find out? D by dt of x to the power n is equal to n into x to the power n minus 1. This is the formula for finding out the differentiation. D by dt means differentiation of x to the power n is equal to n into x to the power n minus 1. This is for physics. That is dx, usually in maths means d by dx of x to the power n only, will be getting it like this. Since here this position is changing with respect to time, we can consider d by dt of x to the power n is equal to n into x to the power n minus 1. Okay, so as an example, if I am d by dt of x cube, what will be the value? 3 into x to the power 3 minus 1, 3x square. This is how we will be finding out the average, instantaneous velocity. Next, one more thing which I need to tell you is acceleration. What is meant by acceleration? Change in velocity divided by time. In the same way, we will be finding out the average acceleration and instantaneous acceleration. Average acceleration means change in velocity divided by average acceleration. Change in velocity divided by time. Change in velocity means delta V divided by time as delta T. Okay, then next is instantaneous acceleration. Instantaneous acceleration means dv by dt. Change in velocity divided by time, dv by dt we will consider to find out the instantaneous acceleration. So average acceleration is change in velocity divided by time and instantaneous acceleration is change in dv by dt. We should differentiate the velocity quantity. So how, this is the theory part, how we are going to do the numerical, we will study now. Okay. So first we will start from the simplest question. In 1 second, a particle goes from a point A to point B moving in a semicircle. Find the magnitude of average velocity. So a particle is moving in a semicircle from A to B. Okay, in 1 second, find the magnitude of average velocity. Average velocity means distance travel, displacement divided by time. What is displacement here? AB divided by time. So what is AB here? For that, in the question it is given radius as 1 centimeter. So we can write this will be 2 centimeters. 2 divided by 1, it will be 2 centimeter per second. This will be the average velocity. Okay, then next is a particle is moving along x-axis. Its x coordinate varies with time axis. Okay, so x equals 2t square plus 4t minus 6. Here x is in meters and t is in second. Find average velocity between time interval t equals 0 to t equals 2 seconds. We need to find out the average velocity. Average velocity means average velocity equals displacement delta x divided by delta t. This is average velocity, right? Change in position, how position will be changing at time, that is x at 2 seconds minus x at 0 divided by 2 minus 0. So first we need to find out x at 2. What is x at 2? 2 into 2 square plus 4 into 2 minus 6. So here 8 plus 8 minus 6. So it is 10. Here x at 0 will be equal to minus 6. So here we will get it as average velocity will be equal to 10 minus minus 6 divided by 2, 16 by 2. Here it is 8 meter per second. This is how we will be finding out the average velocity. Then position is given. Okay, so the next one is a particle is moving in xy plane. Its xy coordinates vary with the time. X equals 2t square and y equals t cube. Find average acceleration between the time intervals. So here I'll write down the question over here. X equals 2t square and y equals t cube. We need to t equals 0 to 2 seconds. Okay, here you need to find out the average acceleration between the time intervals. Average acceleration means average acceleration equals delta v divided by delta t. What is delta v? So here we have xy plane, right? So 2t square y equals t cube. So what is the r, how we can write down? R will be equal to 2t square I cap plus t cube j cap, because x means vector quantity. When we are representing it as I cap, y the vector quantity, as vector quantity we can write it as j cap. So r we got it. Now to find out v, dr by dt. Dr by dt is 2 into, as I said in the previous session, d by dt of x to the power n is equal to n into x to the power n minus 1. So 2t square I can write it as 4t into I cap plus 3t square into j cap. The same kind of question is there in CBSE also. I already explained that in the motion in 2 dimension. That there I explained about this one. So please, so if you have any doubt, please go through those videos. Okay, it will be given in the description box. V equals, so we got the velocity like this. Now we need to find out the average acceleration. So velocity at 0 seconds is required, velocity at 2 seconds is required. So velocity at 0 second will be here, it will be 0, and here velocity at 2 seconds will be 8i plus, here it is 12j, 8i plus 12j. So here v2 minus v1, average acceleration will be equal to 8i minus 0, 8i plus 12j divided by, what is the time? 2. So here we will get it as 4I plus 6J meter per second square. Okay, this is how we will be finding out the average acceleration. So average velocity delta x by delta t, average acceleration delta v by delta t will be the average acceleration. Okay, clear? So this is and some more numericals. We already told that what is that if the distance is it's in between the equal distance or in between equal timing, if the velocity is changing, how the average velocity we can calculate and all. I told you the formula. So such kind of questions also we will be discussing in the next class. Before winding up the session, we will do some more introductory exercise. It's given over here. Average speed is always equal to magnitude of average velocity. Whether our average speed will always be equal to average velocity? No. It will never, it can be equal, but it won't always be equal. Okay, because speed is distance traveled divided by time, velocity is displacement divided by time, right? So distance and displacement will can be equal or cannot be equal, depends on which direction it is moving. Okay, so it is false. When a particle moves with constant velocity, its average velocity, its instantaneous velocity and its speed all are equal. If it is moving with constant velocity, then it will be equal. All this average velocity, instantaneous velocity or all the velocities will be equal if it is moving with a constant velocity. Constant velocity if it is moving, average velocity, instantaneous velocity and its speed, everything will be equal if it is moving with a constant velocity. Okay, so next question. A clock has its second hand 2 cm long. Find the average speed and modulus of average velocity of the tip of second hand in 15 seconds. So here second hand is a clock has a second hand 2 cm long. Okay, 2 cm long. Find the average speed and modulus of average speed velocity of the tip of the second hand in 15 seconds. So 15 seconds means it will come here, right? So this is from here it is reaching till here. So it is covering 90 degree. 15 seconds. Okay. In this motion, it's covering 1/4 of 2 pi r. This is the distance travelled. Divided by time is 15. So we can write it as 2 pi r divided by 60. So here pi r divided by 30, pi into 2 divided by 30, so pi by 15 centimeter per second. This will be the pi by 15 centimeter per second. This will be the velocity, speed over there, and velocity if we need to calculate, we should find out the displacement. Displacement is the shortest distance. Shortest distance means this distance. 2 and 2, Pythagoras theorem while we are applying the displacement, we will get it as displacement will be equal to square root of 4 plus 4, that is root 8 to root 2. This is the displacement. Now velocity will be equal to 2 root 2 divided by 15. So 2 root 2 by 15 centimeter per second. Okay, clear? So next is a particle is moving in a circle of radius 4 centimeter with a constant speed of 1 centimeter per second. Time period of the particle we need to find out, and here so radius is given. A particle is moving in a circular path of radius 4 centimeter having constant speed 1 centimeter per second. Speed is given as 1 centimeters per second. Radius is given. Here speed is given and radius also given. So we can find out the what is that time we need to find out. So in one circular path it will be covering how much distance. Distance covered will be equal to 2 pi r. You can find out using the formula 2 pi r. Speed is 1 centimeter per second. So r is given. Distance covered will be equal to 2 pi r. Time is given as time we need to find out. Speed is 1 centimeter per second. Speed equals distance traveled divided by time. So time will be equal to speed divided by distance traveled. Can find out, right? This is easy one. So this question and the next one, average speed, average velocity and average acceleration in time interval t equals to 0 to t equals t by 4. Give only the magnitudes. So these, the last question, I am giving it as a homework for you, and I hope it is clear for you, and it is a simple questions only. We discussed it today since this is the first day of this kinematics. Okay, so in next class we will be coming with some more numericals which is related to the today's discussion. Okay, I hope it is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.